Hi, Solverscape provides customized solutions for optimizing processes in logistics and supply chain management. In this video, we are going to look at one of the optimization models developed by Solverscape. It's called the Sheet Cutting Optimizer. You have sheets of size 30 inches by 20 inches made of paper or fabric or sheet metal. You need 50 sheets of size 12 inches by 10 inches, 25 sheets of size 5 inches by 10 inches, and 100 sheets of size 5 inches by 7 inches. How many large sheets do you need, and in what kind of pattern should each sheet be cut so that you use the least number of sheets? So the sheet cutting optimizer answers this question. To use the model, we use an application as an intermediate. We call it the solver platform. It acts as an interface between a user and the mathematical model. Data interchange between the user and the model occurs via Excel. A user fills a specific Excel template and passes the file to the solver platform for processing. The solver platform calls the specific model, gets the model solution, and passes it back to the user in Excel format. Let's look at a demo now. So here is the application solver platform. We have three tabs here: models, jobs, queue. Let's go to the jobs tab, which contains the list of historical jobs that we have already solved. So let's look at a job for the sheet cutting optimizer. Click on view. So now the job details screen comes up, and there's a lot of information here, but to make things quicker, we can download this job into an Excel format. So I click on job.xls.x, open it, and now I have the information for that job in this Excel file. So what did I say here, or the user say here? We have a larger sheet with size 5 by 4. Then we need 4 smaller rectangles or shapes of different sizes: 2 by 1, 2 by 3, 1 by 3, 4 by 3, and different number of units that are required. So this is the information that the user gave to the model. Now what did the model say? The model said that you need to have 1.16 sheets to be cut as per pattern 2, 1.5 sheets to be cut as per pattern 4. Now where are these patterns? For that we go to the solution. We go to these plots for the patterns. So how does pattern 2 look like? It looks like this. How does pattern 4 look like? It looks like this. So the model has provided a solution, and this solution is optimal. You cannot use fewer than these number of patterns. So we are going to round this up to the next higher integer, and when we do that, we will get the desired number of smaller units. So if we let's compare what we actually got with what we actually needed. So for example, for shape 0 we wanted 16, but this solution will give you 17. So the goal is that the number of units assigned should be as close as possible, but not less than number of units required, because that means that you are wasting the least amount of material. So that is the solution that the model provided, and it should be better than most of the other solutions provided by other algorithms. So how does a user submit a job to this application? So if you go to the models tab and look at the sheet cutting optimizer, click on edit, and then you have the Excel template here. So you download the Excel template, and now you have the Excel template here. You fill this information as per your requirement. Come back to the jobs tab, click on new job, select the specific optimizer, give any comments, let's say test 1003, upload the job file that you just created. So here's an old file that I have already used. So I upload this file, then select a solver. So I select this open source solver called HEISS and click submit. So now the job has been queued, and then it will be taken up by the optimizer. So yeah, so it's processing now. So let's conclude now. This model can be enhanced to model more complex shapes. These models are based on a technique called mixed integer programming, and they can be applied to large size problems. These models are best suited for problems that do not need to be solved in real time but involve upfront capital allocation. To know more about where we have applied my models, visit us at solverscape.com/case studies. For potential collaboration, write to us at contact@solverscape.com. Thank you.